আজকে আমরা প্রিজমের মধ্যে দিয়ে লাইট গেলে যে 7টা কালারে ডিভাইড হয়, তো সেই 7টা কালারে কেন ডিভাইড হয় সেটা আমরা এখন বোঝার চেষ্টা করব। তো এটার জন্য আমরা কি করলাম, এটার জন্য আমরা একটা প্রিজম নিলাম। ওকে, সো আমরা একটা প্রিজম নেওয়ার চেষ্টা করছি। সাপোজ এটা আমাদের একটা প্রিজম। ওকে, এটা একটা প্রিজম। সেই প্রিজমের নাম দিলাম আমি এ বি সি। সো বুঝতেই পারলাম এই প্রিজমের এটা হলো অ্যাঙ্গেল অফ দ্য প্রিজম, অ্যাঙ্গেল of the prism. Okay, and for a thin prism we have A is less than 10 degree. Okay, তো এবার আমরা এই থিন প্রিজমের ক্ষেত্রে আমরা জানি যে যদি কোনো লাইট, হোয়াইট লাইট এখান দিয়ে, যে কোনো লাইট, যে কোনো কালারের লাইট যদি এখান দিয়ে পড়ে, তাহলে ওটা আলটিমেটলি এদিকে যাবে, দেন এটা এদিকে বেন্ড করে। এই যে বেন্ড করলো, এবং ফলে আমরা বুঝছি যে ওর যাওয়ার কথা ছিল অরিজিনাল রাস্তা হচ্ছে এটা, ওর যাওয়ার কথা ছিল অরিজিনালি ওটা, যাওয়ার কথা ছিল অরিজিনালি ওদিকে। আমরা একটু ডট ডট সাইন দিয়ে দেখাই, দিস ইজ আওয়ার, এটা অরিজিনাল রাস্তা ছিল, বাট আলটিমেটলি ও গেল হচ্ছে এদিকে। দ্যাট মিনস ও গেল হচ্ছে কিন্তু আলটিমেটলি ও গেল হচ্ছে এদিকটায়। ওকে, দ্যাট মিনস ও গেল হচ্ছে যে রাস্তায়, তাতে ওর ডেভিয়েশন হলো। অ্যান্ড দ্য ডেভিয়েশন যেটা হলো সেটাকে আমরা বলছি, দ্য ডেভিয়েশন ইজ কল্ড ডেল্টা। অ্যান্ড ডেল্টাকে আমরা বলছি, delta is equal to mu minus 1 into a। এটা হলো আমাদের ফর্মুলা, mu minus 1 into a, mu minus 1 into a, এটা আমাদের ফর্মুলা। এবার আমরা জানি what is mu? Mu is nothing but the refractive index of the prism, but it depends on কালার অফ লাইট, লাইটের কালারের উপর ডিপেন্ড করছে। বিকজ উই হ্যাভ এ ফর্মুলা, আমাদের একটা ফর্মুলা আছে, মিউ ইজ ইকুয়াল টু এ প্লাস বি বাই ল্যামডা স্কোয়ার। দ্যাট মিনস মিউটা ল্যামডার উপর ডিপেন্ড করে। অ্যান্ড উই হ্যাভ আওয়ার ল্যামডা ফর ভিজিবল লাইট, ভিজিবল লাইটের জন্য আমাদের যে ল্যামডা আছে, আমরা জানি এটা স্পেকট্রামটাকে ভিজিওর বলি, যেখানে ভিটাকে আমরা বলছি ভায়োলেট, অ্যান্ড আরটাকে আমরা বলছি রেড। অ্যান্ড ভায়োলেটের ল্যামডা ভি ইজ নাথিং বাট 4800 অ্যাংস্ট্রমের মতো হয়। অ্যান্ড দ্যাট রেড ল্যামডার is nothing but 6600 এর মতো হয়, নিয়ার অ্যাবাউট 6800 700 এরকম কিছু একটা হয়। ঠিক আছে, সো এটা হলো আমাদের ল্যামডা ভি অ্যান্ড ল্যামডা আর। সো আমরা বুঝলাম, যেখান থেকে ডিসকাশন থেকে আমরা বুঝছি, সিন্স ল্যামডা ভি ইজ লেস দেন ল্যামডা আর, therefore mu v is greater than mu r. Okay, therefore mu v is greater than mu r. And from that formula, this formula, delta is equal to mu minus 1 into a. Therefore if we use violet color, then delta v is mu v minus 1 into a, and delta r is mu delta capital R for red light. Okay, mu r minus 1 into a. And from this discussion we have discussed that mu v is greater than mu r. That's why delta v is greater than delta r. That means delta v minus delta r is nothing but mu v minus mu r into a. Okay, this is actually delta v minus delta r, mu v minus mu r into a. So from these two equations, we can easily conclude that as mu of red and violet are different, therefore deviation in violet color and red color is different. That's why the colors are splitted when passing through the prism, and that is called dispersion of the light. Okay, আমরা এখন এটার একটা let's draw a diagram for this. Okay, let's draw a diagram. Okay, we have a prism. Suppose this is our prism. This is our this is our prism. This is our prism. Okay, let's clear this line. Okay, this is our prism. Okay, close. This is our prism. Draw it. This is our prism. Okay, and this is our prism. Then this is okay. So this is our prism, and name of the prism is ABC. There is a white light which falls on the prism in this way. Okay, so this is our this is our normal at this point of incidence. This is our normal at this point of incidence. Okay, then light actually split at this point into 7 colors at the points. At the point of view, light splits into 7 colors. We draw only 2 colors, extreme colors. One is violet, and we have violet have a more deviation, delta v. Violet is more, and then red. So this is our violet, say, and then it is again deviate in this direction. And for red, say, this is our red color. Okay, then this is again deviate. Okay, so this is for red and this is for violet. So we have the original light is in this direction, original light in this direction. This is our original light. Okay, this is our original light, and this is our original light. This is our original light, incident light. But due to prism, light actually deviate from its original direction, and deviation in the blue light or violet light is deviation in the violet light is in this direction, this much. Deviation in the violet light is in this much. This is the deviation in the violet light. Okay, this is deviation, and this is the deviation in the red light. Okay, this is the deviation in the red light. Okay, just do some decoration. This is the deviation in the red light, and this is the deviation in the violet light. Okay, so this much is deviation in the red light, this much is deviation in the red light, this much is deviation in the red light. This is our delta v, and this much is deviated in the deviation in the violet light. This much is deviation in the this much is deviation in the violet light. Okay, this much is deviation in the violet light. This is the deviation in the violet light, delta r. Okay, and the difference of deviation between these two light, delta v minus delta r, is called angular deviation. So you can just imagine, you can just understand that why this deviation occurs, or why the light is split into 7 colors, because the reason behind this is this formula. Actually, the deviation depends on mu, and mu depends on lambda, and lambda for 7 colors are different. Therefore, mu of different 7 colors are different. Therefore, delta of 7 colors are different. That's why when white light falls on the surface of the prism, when it refracted to the second surface, we have 7 colors: violet to red. Violet have more deviation, red has a less deviation, and deviation difference of the deviation produced by the different colors. That means delta V minus delta extreme colors. This is our extreme colors. This is violet. This is red. These two extreme colors have produced different deviations. Delta V minus delta R. This is called angular deviation. This is called our angular deviation. One more color is called is that yellow color, and that color wavelength is near about 5,600 angstrom. This is wavelength of the yellow color. You see, for violet color this is 4,800 angstrom, and this is red color 6,600 angstrom, and the average of these two wavelengths, these and these, is nearly equal to the wavelength of the yellow color. That's why yellow color is called the mean color, as its wavelength is the mean of the two extreme colors. That's it, it's the mean of the two extreme colors. That's why this yellow color is called the mean color, and wavelength of the mean color is called lambda, and the deviation produced by this yellow color is delta. And what is delta for yellow color? So just I use yellow color. So for deviation due to yellow colors, delta is nothing but mu minus 1 into A, and that mu is called the refractive index of the prism due to that yellow color. Okay, mu is the refractive index of the prism due to that yellow color. Okay, now if we divide this delta V minus delta R means angular dispersion, angular deviation, or this is called angular, not this is called angular dispersion. Okay, this is called angular dispersion. Okay, rather it is called correctly as angular dispersion. And angular dispersion, when divided by the angular deviation produced in the yellow color, is nothing but this is what delta V minus delta R. Delta V minus delta R is nothing but, what is delta V minus delta R? This is mu V minus mu R into A. This is our delta V minus delta R. So here this is delta V minus delta R is nothing but mu V minus mu R into A, and delta what? Delta is mu minus 1 into A. That A is cancelled out. So delta V minus delta R by deviation by yellow light is nothing but mu V minus mu R by mu minus 1, and that quantity is called angular dispersive power. Angular dispersive power. Okay, so angular dispersive power is now becomes omega, is now becomes mu V minus mu R by mu minus 1, and this is nothing but d mu by mu minus 1. Okay, so this is our important formula. Okay, this is actually important for competitive exams, especially in NEET. Frequently this questions asked from this on these relations, and data is given. We can say rather data are given, and you have to calculate either omega or d mu or any other things. But you have to remember what is d mu. D mu is nothing but the difference of diffractive index due to the extreme colors. This is the d mu, difference of refractive index due to the extreme colors. And what is mu? Mu is the refractive index due to the middle color or average color or yellow color, and this is called angular dispersive power. So omega is called angular dispersive power. So this is what prism, light passes to the prism, this dispersion or deviation in different colors occurred, and this is the actually the main reason why different colors actually split it when passing through the prism. That's why prism is called a dispersive medium. That's why prism is called a dispersive medium. So main reason behind this dispersion is nothing but the refractive index of different color is different for the prism. This is the main reason. The refractive index due to different color are different. This is the main reason, and that is why this medium is called a dispersive medium. And from this concept, you can easily conclude that any medium which have the same refractive index for different color, then this medium would be non-dispersive medium, because for that medium mu is become same for the same all colors. That's why there is mu is same for all colors. That's why delta is same for all colors. That's why light will not split it into different colors. Okay, try to watch my video. If you want to join the live class, then you have to contact me. Okay, I'm teaching the same platform in my live class. Okay, till then, bye.